So this class is on automating network configurations with Ansible 101. This will be a series of classes. The next two are scheduled for next Tuesday and Thursday. So same time. So 10 a.m. 10 a.m. Eastern time, 1 p.m. I'm sorry, 10 a.m. Pacific time, 1 p.m. Eastern time, and then whatever other time zones that will be. So they'll be live. Maybe add a little, oh yeah, de-esser, yeah. Let's see if I can do that for maybe for the next one. So this class is on, I know a lot of people are looking to do automation, looking to learn automation, and there's a lot of resources out there, but they're all fairly complicated. So I wanted to make just a beginner's course into Ansible, and this is based off of Jeff Geerling. So I don't know if you're aware of Jeff Geerling. He is a YouTuber, and during lockdown in 2020, he did a free course on Ansible, and that's how I learned Ansible. It was a great course, but it was oriented towards server administration because he's a server administrator. He does a lot of videos on like Pi, like the Pi little boards and some other stuff, storage and so forth. So he's a server administrator. And there's a different use case for Ansible for networking, of course. And so this is a class which was inspired by that. So I thought I'd just put it out there free. I've been doing content for different types for Ansible for specific companies and so forth. But this is going to be just a general vendor neutral Ansible for networking class. So who am I? Oh yeah. So the next two classes, Tuesday, April 15th, and then Thursday, April 17th. And they will start at 10 a.m. Pacific time, and whatever time zone you're in, that'll be live. And again, the videos will be after. There'll be videos after posted on YouTube. So who am I? My name is Tony Burke. I am a network and automation instructor. So for the past, since about 2008, I've been both consulting and doing classes, training, developing courseware for various technologies. I started out in the Cisco world. I was a Cisco CCSI, Cisco Certified Systems Instructor, number 32063. And I started out teaching like the Cisco ACE load balancer, if you remember that. That was kind of a terrible product. I taught MDS, taught UCS, love that product, Cisco UCS. Taught Cisco ACI, complicated product, complicated legacy. MDS, storage, and then I started getting in more into automation. I moved into the Arista world, and that's what I've been teaching for the past 5 years, past 5 or 6 years. So, and then more and more of what I've been teaching is automation. So data center, campus, automation is where I've been doing most of my teaching, and I'm a skydiving instructor. So I've taught, I don't know how many people how to jump out of airplanes and survive. The only current certification I think that I have is the Arista ACE level 7. So they have a number. It's an IPv6 number. So that's my Arista ACE level 7 number. That's their highest certification. So there I am about to skydive. So like I said, it's inspired by Jeff Geerling's free YouTube course. And we're going to learn about using Ansible for network automation. A couple of things that we can do. We can like modify existing configurations. We can create new configurations from templates. So I'll show you some templating systems and then deploying those configurations that we create. So that's generally what we use it for. There's a couple other things we can do, just some random tasks, like we can reboot systems, upload software, that kind of thing. So all of the artifacts, playbooks, inventory files, etc., they're going to be on GitHub. So let me post a link to the GitHub repo, so that everything here will be on GitHub. So if I do any updates or anything like that, it will be available on GitHub. Anything I do in this class, and I've already got some stuff prepared, and that will be on GitHub. So that's in the chat right now, and let me put it on. Let me go ahead and edit this with the link. There we go. So there'll probably be some on the fly slides. So ANCWA, so automating network configuration with Ansible 101, YouTube class 2025. So what is Ansible? Ansible is an open source automation platform that's used extensively in the IT world. So it's used a lot in server administration, and it's being used more and more in network administration. I would say it's probably the #1 network automation platform. It's not the only platform. There's others out there. There's like Nornir, raw Python scripts. People have used some of the other automation platforms like Puppet, Chef, and SaltStack for network automation. But pretty much it's an Ansible world these days, both in the server world and the networking world. The Ansible project is owned by Red Hat, although it's still released under the GPL license, so it's still free. There are extra bits you can pay for from Red Hat, so they do have some parts of Ansible that you do have to pay for, you don't get for free. But everything in this class is going to be the free version. So it's all, you can follow along, you can replicate everything in this class, and I'll provide all the files so that you can replicate everything in this class. And you can do everything for free. So you don't have to pay anyone any money. So other than the hardware that you're using, running this on, of course, it'll be free. A little bit of Ansible history. It is created by Michael DeHaan around 2012. I think that's when the first release was. Michael DeHaan has done a lot in the automation world. He created Cobbler, which is like a zero-touch provisioning system to install bare metal Linux systems. So if you've got a rack of servers and you want to get Linux on every one of them, it's like a jumpstart. I don't know if some of you might be familiar with the old Sun Solaris jumpstart system. It's a network boot to install operating systems. That's what Cobbler did, if I remember right. So then he created Ansible. The project was purchased by Red Hat in 2025, but like I said, it's still open source. So Red Hat's the steward of it, but anyone can contribute. And it was originally created for servers. So Michael DeHaan he's a server person. So he was doing server installations and so forth, and he wanted an easier open source free version of configuration management system. There were others before it. So some of you might remember Chef, SaltStack, Puppet. In the 2010s, Puppet it used to require an agent. I don't think it requires an agent anymore, but it was very popular in the mid 2000s, early 2010s in the server world. And we were dabbling a little bit with it in the networking world. There were agents you could put on Nexus and XOS, for example. And I think also, there was an agent for Arista EOS and probably Junos and some others. But it never really caught on in the server world for a lot of different reasons, partly because we were still figuring out how we were going to do automation in the networking world. Most of the network operating systems really didn't have a good mechanism to install an agent in them. So there's a couple different, those and other reasons were why we never really adopted network automation with any of the other platforms. But Ansible came at the right time, and it had the right approach. So Ansible is agentless. It's always been agentless. And it can connect through things like NetMiko or APIs, whether they're vendor-specific APIs like NX API or EOS or eAPI for Arista. Or it could go in through some of the more open APIs like OpenConfig, GNMI, NetConf, RESTconf, or even just NetMiko, just screen scraping. So those were already built into those environments, so it made it pretty easy for Ansible to go in and do what it wants to do. And because of that, Ansible because Chef, SaltStack, and Puppet were never really popular in the networking world. Pockets here and there. It's all an Ansible game now. And Puppet, Chef, SaltStack, they are shells of their former selves in terms of their usage. Puppet used to be pretty big. They're actually based, or they were based here in Portland, Oregon. In the building I live in, actually, one of the founders of Puppet used to live in the same building as me. But that went by the wayside. So it's Ansible. What can you use Ansible with? In the networking world, we use it with routers, switches, firewalls, load balancers, and using either APIs or NetMiko, or most of these network devices have ways that Ansible can connect with them. And what do we use it for? We use it to modify existing configurations. So most devices in the networking world are one of two different types of device. I'm going to make a new slide here. There is the single configuration file device. So like a Cisco router with running config. That's the most common example probably that you're familiar with. These are devices. So most of the vendors have this. So Juniper, Arista, Cisco. There's one file on that device that comprises the entire configuration state. So it's not in a little file over here, not a little file over there like most servers are. There's just one file like running config or their equivalent of whatever. Like I can't remember what Juniper calls their config. So most of these devices have a single configuration file. And what Ansible does, Ansible modifies that config, or Ansible modifies that config. So it goes in and either modifies the existing config as it exists on the device, or it generates a new version of that config somewhere else, typically on the Ansible control node, using a templating system and data models, combining them all, and then presenting and then uploading that new config. So typically one of those two ways. The other type of devices are the controllers. And so they're responsible for other devices. So Cisco ACI, for example, has the APIC controller cluster. In ACI, you don't go into leafs and spines to make configuration changes. You go into the cluster. You go into the APIC cluster. And there's three ways to make a config change on an ACI APIC cluster. You can go in through the GUI. You can go in through the faux CLI. It's not really a CLI. It's just a Python front end. Or the REST API. And the REST API is the native way that ACI is configured. And there's configuration state distributed through all these things called managed object models, MOMs. They're XML files with information about things like VRFs and bridge domains and switch selectors and all that. And so there's not just one config file. So you're just modifying that existing state that exists on that device. Wireless controllers are the same way. So whether it's a physical box that you have on site as your controller, or if it's a cloud provider, or cloud instance of that controller, we gave up on manual configuration wireless access points like 2 decades ago. So we realized that if we're going to have 1,000 of these devices in a building or on a campus, or 10,000 or whatever it is, we're not going to go in and configure these devices individually. We're going to use a controller. We're going to control through the controller, and it's going to push it out. So Ansible can work with these as well. So Ansible has modules that will go into ACI and will go into the controllers, and Ansible has modules that will go into the the wireless controllers and whatever else is like that. Most of the routing and switching devices are not controller based, other than ACI. The other one is the Big Cloud Fabric, or the CCF, the Converged Cloud Fabric. So Arista bought Big Switch, and they renamed the Big Cloud Fabric to the CCF, Converged Cloud Fabric. So we're going to modify the existing configuration. We're going to generate configurations using a templating system and deploying it. Or there's even platforms built on top of Ansible. So Arista has a really cool project called Arista AVD. And that is a way, it's like a templating system. It uses Jinja, but it's got its own data models. And it will generate leaf-spine topologies for EVP and VXLAN. It will generate standard layer 2 configurations and even MPLS fabrics. And we'll do a demo of that as well. So those are what we typically do with Ansible. What we don't use Ansible for is comparing state. Ansible's not good at any kind of application logic. So for example, if I query a device and I find it's got state X, then I'm not going to really be able to do much with that information. It's not really built for that. I mean, you can try to do it, but it gets really awkward really quickly. So we generally don't recommend Ansible for that kind of stuff. Another one we might not use it for is let's say I want to search for a MAC address. I've got a big fabric. It's got like 50 devices, and I'm trying to find a MAC address, and I don't. It's not really good for that kind of thing. You can write a Python script that'll do that pretty quickly, pretty easily, or maybe put a front end for it in Flask or something like that. But it's not really good for that kind of task. So anything that involves programming logic or comparing states or trying to what's the word I'm looking for? Trying to consolidate states, trying to reconcile states, really not good for that. You can do it, but it gets pretty awkward. All right, so this section, I'm going to do some demos. I'm going to show you what Ansible is capable of doing before we get into how to do it, because I think it helps to see what the possibilities are before we do it. So let's see here. Open up. Oh yeah, I wanted to show you another project that I've got going on. It's called Project Nerd. And what Project Nerd is, it's a set of instructions. So one of the challenges that I think a lot of people have had with doing automation, learning automation, is setting up an environment that you can practice it on. There are some really good tools. Ivan Pepelniak made, it was NetLabs, but it involves a lot of moving parts. And when you're really starting out and you just want to play with a little bit of Ansible, a little bit of Container Lab, there's so many parts, or the instructions are like one small part of it. And then you have to figure out how to work Linux and figure out how to work Container Lab and then Docker and all this stuff. And I didn't know of any single set of instructions that would just build you a simple virtual machine that had enough memory to run a simple leaf spine topology and it'd tell you how to install Container Lab, Docker, and some other stuff. So I created what I call the auto box. Well, I didn't create really anything. I just created the instructions to build what I call the auto box. And it's a Linux VM, runs Alma Linux. It runs something called Code Server, which is what you see right here. So this looks like VS Code. And it is VS Code, but it's running as a web app on the Linux, on the Ansible control node. So I can edit the files on the control node directly, and I can run the playbooks from that control node all in one place. So there's other ways to do that, of course. You can have VS Code on your desktop and then have like an SSH tunnel to an Ansible control node. But that's kind of complicated to set up for the first time, especially if you haven't done it before. So this is just all-in-one instructions on how to build this particular VM. And you can build it, and if you can make a VM that has 8 virtual CPUs, although I'm going to change this, I think you can run this on 4. In fact, this environment right here is just running on 4 virtual CPUs, 16 gigabytes of RAM, and then 60 gigs of storage. If you can make a VM on any hypervisor that has that, then you've got everything you need to do what I'm doing here. So everything that you see in this, you can build by just a couple of commands in less than 30 minutes if you have a hypervisor. So we install Linux. We're using Alma Linux. We install Python, pip, Ansible, enable some repos, install Git, install Code Server, enable it through a self-signed certificate, install Docker, get a network operating system. We're going to use containerized EOS from Arista. And I chose that because it's a popular network operating system. And Arista makes it pretty easy to get for free. And install Container Lab. And then I've got some built-in topologies that you can run as well. So you can get that all up and running in 30 minutes or less. So this is right now. This is the base. This is running this what I call it the auto box. The only thing that I added to this whole thing was the instructions and just here do this, this, then this. I wanted the simplest way possible. So like I didn't do things like Python environments because Python environments, if you're new to Python, if you're new to automation, there's a lot of moving parts. It's really complicated. So when I teach skydiving, we teach in very discrete layers that we don't throw everything at the student at once. And that's how I approach teaching networking is I try to introduce as few things to someone as possible. Like I don't want to throw Vagrant at you, Python environments, SSH tunnels. I want like 20 commands and then you're done. So that's what the Autobox is. Let me post a link to the Autobox. It's under Project Nerd. I'm planning on building some other ones too, like doing a Grafana, Telegraph, InfluxDB, the TIG stack, TIG, Telegraph, InfluxDB, and Grafana. So building those type of boxes to get started with that. But the first one is the Autobox. So put that in the chat room there. So again, if you've got a hypervisor, you can make a VM with 16 gigs of RAM. It says 8 vCPUs, but I'm running it on 4 right now, so I'm probably going to update the instructions. And 60 gigs of storage, and that's it. All right, so I do have everything set up and running right now. So if I do a docker, sudo docker ps, we can see I've already got a leaf spine topology up and running right now. Let me copy that, open that up. So this is what it looks like. So I've got 4 leaves. I've got 2 spines. I don't need AI for this. And then 2 hosts. And so that's what's running currently. And if I go into the default password is admin. You can see there's not much there. It's got the basic config that the Container Lab put onto the device. So I didn't do anything to these switches, to these devices. Again, 4 leaves, 2 spines, and an external router. I didn't do anything to them. All the config on there is what Container Lab did. So let's go into our automating network configurations with Ansible directory. And the first one is a demo of just simple Ansible. So these are the live demos. I've already got them pre-made. We'll take a look at a couple of files here. We have an inventory file. So in Ansible, we need an inventory file. In the next class, we'll go over the specifics of that inventory file and how to make one and how you would design one. But just know that we need an inventory file. And the inventory file needs to have the inventory of the devices that we're going to configure. So that's these devices right here. And we just got our 4 leaves and 2 spines. I'm going to add some more to this. And I'm going to have infrastructure, children. I forgot to add these actually, so I need to add these. So infra, hosts, host 1, hosts. Host 1 and host 2, and then routers, R1. So I didn't include R1, host 1, or host 2. So I'm going to put those in there just so we can configure them. And let's say that also, by the way, you'll notice we put the password in the inventory file. That's not best practice, of course. We don't want to have plain text passwords in plain text files. There are ways to hide it. There's Ansible Vault, HashiCorp has one. So there's ways we can encrypt these without putting them into flat files. but it's a lab environment and we're trying to keep things simple. So this is what we're going to do. All right. So we have all the credentials and all the connection parameters we need to get into these Arista EOS devices. You can do it with, most of the other network vendors support Ansible in some regard. I just chose EOS because I've been teaching EOS for the past 6 years, and and it's very easy to get a free copy versus like some of the other, like Cisco. Like Cisco makes it very difficult to get a legal version of one of their network operating systems to run in a lab. They put it behind their register walls and so forth. And usually you have to find an image that fell off the back of a truck. I'm not giving legal advice on that one, but these containerized images are free to use and legal to use in a lab environment. So they've got a containerized EOS and a virtual EOS. So that's what I'm using here. Let's add a user. So I've got what's called a playbook here. And a playbook is we're going to use this to add a user to a device. I am going to change this, the SSH key, because that's not the SSH key in the system. I'll do create a quick key. This is a public key, so it doesn't matter that it's being splayed all over YouTube. If I did the private key, that would be a problem, but the public key doesn't matter. So what this playbook is going to do is it's going to go to all of the devices. So all of the fabric devices, the router, the 2 hosts, and then add a new user called Tony and give it the privileges, and I'll be a super user, and then add an SSH key. So after I run this playbook, I'm going to be able to log into all these devices via my SSH key. So let's go ahead and run this playbook. So Ansible playbook, single add user. So it goes into each device, makes the change, and now if I go SSH Tony at leaf1, I'm logged in without a password because I authenticated using my SSH key. So, think about if this were 5 devices or 50 devices, it takes about the same amount of time, maybe a little bit longer for 50 devices, but just by a couple of seconds. You can make some significant changes very rapidly and very accurately. That's one of the reasons why we're doing network automation. Let's do another one. Let's add a VLAN. So let's go, if I go to a leaf and I do a show VLAN, we have just the default VLAN, VLAN 1. It's always going to be there. But now I want to add leaf 1, or now I want to add VLAN 100. And I'm going to add it to a group called leafs, which in my inventory file is just leaf 1, 2, 3, and 4. And so that's what I'll do. I'll run Ansible playbook, single add VLAN. And now it's going to go into all 4 leafs and add VLAN 100. So if I go to leaf 1, show VLAN, and now VLAN 100 is there. So think about how quickly I could do that across like 100 devices, 50 devices. Grab a different VM here. I actually have an environment that has 50 leaves. Maybe I might have forgot to spin it up. Yeah, I did. So let me start that up. All right, spinning up. It'll take a little while because it's 50 leaves. All right, so simple demos, simple things. I've got access to the different vendors will have different modules that will be able to do these kind of things. And we can take a look at Arista's. So the Arista namespace here, Arista EOS. And so we have different modules that we can use to modify different aspects of the configuration. I'm using the VLANs module and the user module. So that's how I added VLANs and users. Hold on a second. Need a drink here. Okay, so pardon me. So these modules, and you can see over here, there's other vendors that have their own, and these are just the ones that are maintained by Red Hat. There's others that are maintained by the vendors themselves. So like if we look at the Cisco namespace, there's ACI, DNA Center, which is now, what is it, Catalyst Center? I don't know why they keep renaming things. Intersight, iOS XR, NXOS, UCS. So these are all modules that you can use to interact with these devices natively. Let's check out Juniper. Juniper's got some too. So these are these, and then there's these vendors might have made their own as well, and that's available in a centralized repository called Galaxy. So any questions so far? Chat room's a little quiet. Okay. All right. Let's see here. All right. So next up for a demo. So if I wanted to add like VLANs and users, and I wanted to do a lot of them, like, this is one VLAN. This is called a playbook. The playbook has a task, and we're just adding one VLAN, but maybe I want to add multiple VLANs. So I can use variables. I can use these things called data models. And a data model is an abstracted representation of desired configuration state. And we'll store them, if we're using Ansible, we'll typically store them in YAML files. So this is a variable file, and it's got a list of VLANs here. And we've got a name of the VLAN, and we have the VLAN ID. So what I can do is I can loop through this list. I can iterate through this list and then add multiple VLANs at the same time. So I'm doing loop. I'm using the variable VLANs, which here is this key, this dictionary here. And I want to loop through that list of VLANs, and it's going to add them to all of my leafs. So I can do that. Loop add VLANs. Now it's going to go into each device. You can see that VLAN 100 is green because it was already there. The others got added and they're yellow. That means that they made a change to the existing configuration. So we're going into each device and we're modifying the configuration state as it exists on the device. I can also run some, so I can do that with just about anything. I can also run some arbitrary commands. So many of you have probably at some point in your career forgot to do a copy run start. So none of these I've done a copy run start. So it's not saved any of the configs. So I have a playbook that I can do to run arbitrary commands on these devices, including the command copy running config startup config. So let me run that. So it goes into each device and just does copy run start. Cool. I can also backup configs. So each of these devices, maybe before I do a change, I want to run a backup. So it's going to run that and deposit them into the directory called backup configs. It's got the running config on the device plus a time and date stamp. So these are pretty simple things that we can do. When we do these things, Ignat says, "Sleepy, going to bed." Okay, no problem. Thank you for listening, and yeah, I'll post the video afterwards. So when we're doing these things, it works well with existing methods of operations, because when we're doing it this style, when we're modifying the configuration that exists already on the device, then we can still manually configure these devices, as long as we don't overstep each other. But that's an issue even without automation. You don't want one user or one administrator going in and overstepping another, overriding their config, because that can still happen here. But you can do manual configurations and automated configurations at the same time. And that's because we've kept the source of truth on the device. So let me do a new diagram here. Some of these PowerPoints will be on the fly. So source of truth, where do we keep our source of truth? There's two places when we're doing automation, generally speaking. One of them increase this text. Is going to be the source of truth will be on the device itself. So where's my little, right here. Make this gold. So what do I mean by a source of truth? The source of truth is the one place you go to make a configuration change. There can only be one, like the Highlanders. There can only be one place to make a config change. You never want to have two places to configure the same type of thing. So here I've got a router, maybe it's R1. The source of truth is the running config on the device. So if I'm going to go in as a person, I'll make a little person icon here. This is how I make a person icon. I spent the last 20 years knee deep in PowerPoint, so I'm pretty quick with it. So they go in and do some kind of configuration, and then I can have Ansible go in and do some kind of configuration as well. And they're not going to collide with each other, well, at least not necessarily. They could. But we were both working on the same source of truth. So manual CLI config and automated CLI config can coexist. The drawback to this method is we don't have a centralized source of truth. We don't know the entire fabric state. And there's advantages to doing it that way. So the next demo that I'm going to show you is a centralized source of truth, where we are going to... Now this is going to negate our ability to normally do manual configurations. So the source of truth is going to be on our control node, our Ansible system. And it's going to be comprised of two things. One will be the data model. So that's the variables. And the other one will be a template. So I'm going to run Ansible, and it's going to take the data model plus the template, and I will get a config out the other end. And what Ansible will do is it will take that config that I made and replace the existing running configuration on the device. So there's two steps here. There is the generate, and that uses the data model and the template. And then 2 is deploy. We're going to use the data model and the template to make the config, and then we'll use the deploy playbook to push the config to the device. Now this will overwrite whatever exists on the device. So that means if I go in and make a config change manually, the next time I do a push is going to erase the config. So from now on, if we're going to put the source of truth centralized, all my changes are going to have to happen on either the data model or the template. Probably the data model, But we might make changes to the template as well. I got some suggestions here. Yeah, so you're a developer. Okay. Yeah, this is meant for automation noobs and developer noobs, and not so much the networking part. Although this part is pretty useful for networking for developers. Just knowing about the difference between all of our configs. Developers, if you're a server administrator, you're used to the configuration state being scattered across the file system of a server. In the networking world, it's just one file, just one place that we make these changes, either running config or the equivalent. Sorry, need a swig of water here. So this class is going to be about an hour or so, and the next class will be sorry, I had to burp there. I had to burp there. On Tuesday, will be about an hour and a half, something like that. All right, so we've got the source of truth somewhere else. So right now in this demo, in demo 2, Jinja, we are pulling the source of truth off of the devices and we're putting them here. So I have a template and it's written in Jinja. Oh, I need to put in what you're seeing right now, all of this is VS Code running as a web app. It's called Code Server. Excuse me. And you notice there's no syntax highlighting. It's all just white text on a black background. We can install an extension for Jinja. I forgot to install this. And so what'll happen is now I want to go to, now I've got syntax highlighting. So it's, so it also does a little bit of what's called linting, which is like a spell checker. So if I make a mistake in my syntax, I'll usually get like a squiggly line letting me know. I should also install a Ansible. So this one's by Red Hat, and then a generic YAML one as well. Yeah, it's already installing. Cool. All right, so I've got some variables here. This is what I call the data model. And again, a data model is an abstracted representation of desired configuration state. It generally does not have native syntax. In fact, I could use this data to generate a config for Cisco, for Juniper, for Arista. So the goal here is to build an EVPN VXLAN underlay using OSPF as the routing protocol. So if you're not familiar with what EVPN VXLAN is, it's a fabric. It's a data plane and control plane that lets you build out leaf spine topology, but still have layer 2 adjacency. So you can do things like vMotion. Every network is available in every rack, that kind of thing. And it's built in 4 layers. So the first layer is the topology. That's how the leaves and spines are connected to each other. So we've already got that. So we got the topology. The second layer is the underlay. The underlay's only purpose is to create loopback interfaces on each leaf and spine and then put them into a routing table. That's it. That's all it does. It provides IP connectivity between loopbacks. So that's all we're doing right now. We're not doing any of the other stuff for EVPN. We're not doing the overlay, not doing stretched VLANs, EVPN services. This config, again, as simple as I can make it, is going to build us out that underlay so that the routing, so that I can ping any loopback from any other loopback in this fabric. So I have some of the global options. We're going to use OSPF. We're going to throw everything in OSPF 0. The point-to-point ports, Container Lab and Docker doesn't like 9216 for MTU, which a lot of the switches will do, the physical switches. So we're setting the MTU to 1550. And that's because that a normal host MTU is going to be 1500 and then 50 bytes on top of that for VXLAN. So 1550. This is the point-to-point MTU, the MTU between the leafs and the spines. VRF is MGMT. The gateway is that. Our devices are point-to-point interfaces. For leaf 1 will be Ethernet 3 and Ethernet 4. So we can see Ethernet 3 and 4. These are our point-to-point interfaces. These are layer 3. And we're going to use IP unnumbered with OSPF. If you're not sure what that is, don't worry about it. Just know that I've got an abstracted representation of the information that we need in order to build this config. So I've already done this. I've already set this all up. And you notice there's no syntax here. The syntax comes from the template. So here's my template, and it's got some SSH keys in here. I'm going to actually replace these keys because I don't want to lock myself out here. Should put that in the notes. So I'm going to just replace for that user and replace for that user. And I'll change it to Tony. Actually, no, I'll change this one to Tony. So this is going to be the entire config. None of the existing config will survive. It's going to overwrite the entirety of the old config. That way we know my state, this state is the current state. All right, so we have two processes. We have the build process. So the build process, oh yeah, I need to fix this. The build process goes to templates, reads in the template, feeds in all of the variables from our variables file, our data model, and then plugs in the values. And sometimes it'll do things like loop. It's gonna, in this case, we're looping through all of our P2P interfaces. That's this here. And then it will say IP address unnumbered, IP OSPF area, and then plug in that variable there. IP OSPF network point to point. So if I go to one of the switches, I'll do watch one show IP OSPF network or neighbors. So OSPF is not enabled on this device now. So the first step is to build the config. So go to the demo2 directory. I'm going to run Ansible playbooks, build configs. All right, doesn't like something. Oh, yeah, I need to fix a couple of things here. I changed the host names. Try that again. Destination directory does not exist, so I need to make that directory. So I got some things I need to fix in this, but that's no problem. I need to make a configs directory. There we go. So it just generated these configs dynamically. So you can see here, Ethernet 3 and 4. I've got no switch port, MTU, IP address. It found all these values from the not this one. Let me hide this so I don't get confused. From this variable file here. So pulled all those values out, plugged it into the template, and then generated a config. one unique config per device. So now I've got the configs. Let's deploy those configs. So I've got another playbook that will go into each device. It will save the config. It also backs up the last version of the config in case we need to revert. So let's go ahead and deploy configs. It's going into each device. It's deploying the config. And we should see the OSPF come up in just a second here. And there it is. We're getting, I'm not sure why there's a beeping out. Oh, there we go. Okay. Yeah, there was beeping outside my window. I don't know if the mic picked that up. All right, so that's all it took. I used, so if I'm going to make a change to my fabric, I'll typically just make them in the data model. And because I'm not working with esoteric syntax, more people are able to make accurate changes here. And then I can also make changes to the template if I need to. Although most of the time we're going to make changes to the data model. So if I go in and do show IP route, you can see I can ping every loopback from every other loopback. So I just built out a configuration for all these devices. And then if I go into, oh yeah, I want to go into the other directory. I want to show off a little bit here. By making changes to 50 devices. Where did I... Something happened to one of my devices. Did it crash? Yeah, that might have crashed. May not have had enough RAM for this. Maybe not. Okay. All right, so that's one. Those are two ways that we can run Ansible. I'm going to show you another way, one more way, and that is going to be vendor specific. So Arista has a project called AVD, and AVD is it runs either on top of Python by itself, or you can run it with Ansible. We're going to run it with Ansible, and it has ways to build out leaf spine topologies. So I've got a file here called fabric that defines my underlay and overlay, which interfaces are plugging in, and which routing protocol I'm going to use for the underlay and overlay. And I've got a file for my EVP and services, so my stretched VLANs. I've got a file for my racks, how they're going to connect to different devices. And this will build out the entirety of the EVP and VXLAN network. And I don't have to make a template. Arista provides the templates here. I just provide the data and the data models. And it's got the same thing. We've got build, deploy, and there's also a testing module. So it'll go in after we do the deployment and then test things. Like, for example, checks to see if every loopback can ping every other loopback, make sure that the interfaces are up, making sure that the neighbor on the other side of a layer 2 or layer 3 link is the actual device that we think it is using LDP. So I do need to install a newer version of Python. So let me do that real quick. And then Python 3 pip. Then I have to change my Python version. This is where I might use something like Python environments, but I'm gonna do it really simple. And that's just a static link. I'm gonna link user bin Python 3.11 to user bin Python 3. Now, if I do pip3 install Ansible, I have to install Ansible again because I have to install it for this version of Python. So it's got to do that real quick. And install PyAVD. And then I'll install Ansible Galaxy Collection, install Arista AVD. It's a set of modules. Ansible has a centralized location. If you want to download collections of these things called modules, modules are the code necessary to do the things we want to do on a particular device, whether it's Cisco, Arista, Juniper. So it's all stored centrally, so installing them is super easy, barely an inconvenience. Getting close to the end of the this lesson here. All right, so that's all installed. So I'm going to do a playbook called build, and it goes in and I need to install Python library. There we go. So built out the configs. Now I'm going to deploy the configs. That's going to overwrite what's existing on there. So build, deploy, and then we'll run a test. I'm also going to go in and manually configure these devices. I'm just going to put a quick manual config on. Based off of these. So what I'm doing is on leaf 1 and 2, I've got a 4-way port channel. And I'm going to put on VLAN 100. And on rack 2, which is leaf 3 and 4, I've got a 4-way port channel for host 2 on VLAN 200. And the IP address, the gateway, the Anycast gateway is 10.1.100 and 10.1.200. So these are all defined in these data models. I should be able to ping. Yeah, I can ping my gateway there. And so for host 2, put in a port channel, a switch port, IP address 10.1.212. Set my default gateway to the Anycast gateway. And I should be able to ping the other host. I did put in a gateway. Yep, there we go. Okay, yeah, so I can ping across the fabric. So that's all it took me to build out an entire leaf spine topology. And if I had 50 leaves, it would take just about the same amount of time. And then I can run a test. So let's do that. I'm going to run a test. Oh, that was deploy. I think it's timing out because of the IPv6. Let's just run the tests. Oh, we need Anta. So pip3 install Anta. There we go. Test. So it runs a couple hundred tests per device. Things like checking BGP status, pinging between loopbacks. You can also make your own tests. So Anta is Arista's Python-based testing suite. Because that's one thing we're not doing in the software world. We do a lot of unit testing, integration testing, load testing. We don't do much testing in the networking world. And I think that's starting to change because we can do things like here we're doing these unit tests. After we do deployment, let's ping every loopback from every other loopback. You know, think about when you do a deployment on a device that, do a deployment for 100 devices. Are you going to log into 100 devices and run 20 different show commands? Probably not. What you're going to do is you're going to do a couple of devices, do 2 or 3 commands, and yeah, that's probably okay. And wait for tickets or wait for calls from customers saying that things aren't working. That's usually how we do it. So this is, we're being much better about testing, and we'll see the reports here. See the test results. So we did have 10 tests fail. And it tells us NTP, for example, is a failure. And then there's a reachability between some of the leafs and spines. So I'll have to figure, maybe I didn't set something up right. But I know that there's something wrong now. So yeah, those are the 3 demos. I will fix, there were a couple bugs in the demos. I'll fix them and push them to the GitHub repo. So the GitHub repos are in the chat if you have any questions about that. I think that's it for this class. So in the next class, we're going to go through the different components of Ansible. We'll talk about the control node, how to build a control node, how to size a control node. We'll talk about the Ansible configuration file, the inventory file. We'll spend a lot of time on the inventory file. And then we might even get into variables, how we do variables in Ansible, because that's going to be very important when working with Ansible. So yeah, so I was shooting for about an hour to an hour and 20 minutes, and I think we're just about in the middle of that range right now. So any questions? Before we wrap things up here, I want to thank everyone for watching. We didn't get too many streamers, but that's okay. Hopefully, when this video goes live, because it will be on there, I will be able to get some more for the next one. Yeah, Douglas Jackson says, nice to see that customer-based testing harness exists in the networking space as well. It does, but it's not widely used. It's I would say less than 2% of environments do a testing harness after a deployment. So there definitely needs to be more of that. It's one of the more exciting aspects of networking because, like, think about how terrifying those changes are. So there's a Gene Kim. If you're a software developer, you've probably heard of this guy named Gene Kim. He was one of the authors of the book, The Phoenix Project, and he does a lot of talks about software development, agile, all that kind of stuff. And he has a really great quote that I've stolen from him for the networking world, but he was talking about the software world. And so Gene Kim quote. So the quote goes like this. I'm paraphrasing because I don't remember the exact quote. When we make a change, we are scared because there is a high cost of failure and a low confidence of success. And a low confidence of success. So you might have said it opposite. So there's a low confidence because there is a low confidence of success and a high cost of failure. Now think about that. That sounds exactly like the changes we do in the network. We have a low confidence of success when we make a change in the network and a high cost of failure. So what they did when they started doing this agile development where they would make a change, then they would do testing before they would deploy, then they would deploy, then they would test after they deployed. Roughly speaking, that's a CI/CD pipeline, basically. It was to address the low confidence of success and address the high cost of failure. So how are we going to address the low confidence of success? Like, think about all the mistakes that we make that cause failures when we're doing network deployments. One of them is typos or pasting errors. You know, one thing we should really not be doing anymore in 2025 is copying from Notepad and pasting it into a terminal window to make a change on a network device. We should absolutely not be doing that. We have all the tools we need to not do it that way anymore. It is fraught with danger. You could be pasting into the wrong window. There could be a syntax error in your text that you're pasting, and it pastes so fast and scrolls by so quickly, you don't catch that there was a syntax error on one of your lines. So now you have the old state, which is no longer on the device, and you have this new state, which you're trying to get onto this device, and neither of those are what's there. Instead, there's this quasi state of kind of your config, but you missed a couple of lines. And so that's we should not be pasting configs into terminal windows in 2025. So that can solve a whole bunch of problems if we stop doing that. There's tools, Python, Ansible, Nornir to push configs out from text files. Don't paste, don't do notepad ops. If we're generating configurations from templates and data models, as long as the template and the data model are correct, then we're going to get a correct config. So we can have a much higher confidence that when we push a config, it's going to be the correct config. And then after we make a change, we can test that deployment to make sure that everything's working the way that we think. Let's say a problem comes up and the testing didn't find it. Well, we just make a new test. So anytime we have a new problem that we've never seen before, we can write a test to check for that. So our pre-deployment testing and our post-deployment testing, the tests get more and more intricate as we go along, or get more and more involved, more and more edge cases that we can detect. And then finally, if things still don't go right, then we have a way we've got the old configs, we back them up, we can just push those instead and to get back to where we started. So not to say this is going to fix every problem that we've ever had in networking, because there will still be problems, but this can dramatically increase the confidence of success and dramatically decrease the cost of failure, because we're not trusted in the networking world. No one really trusts us. When we say we're going to make a change, people start looking at us weird and being like, "Are you sure that we can't push this off until like December?" Or no one makes changes in December. So, all right, that's all I wanted to say about that. So, yeah, it drives to the data center to terminal into each device and restore the config. If we have backups of configs and we have console access, that should hopefully cover everything. A terminal server. I used to make terminal servers out of old Lucent Portmasters or Livingston Portmasters from the 90s. But anyway, let me know if you have any questions. Let me put an email address on here. So I have a special email for this. Tony the Automator. So if you have any questions, you can send an email there. I think that's the email address. I just made it, so let me just check. Yeah, I think that's it. All right, I'm going to shut off the stream now, unless there's any other questions. Yep. Next week, we will go into components of Ansible. So thank you for watching.